Learn like a pro.
Hey everyone, and welcome. Today, we're going to go on a journey into the tiniest scale you can possibly imagine. We're going to get to know the atom. Yep, the fundamental building block of absolutely everything around us. So let's just dive right in. Have you ever just, looked around you, at your chair, the air you're breathing, even the stars in the sky, and just wondered, what is all this stuff really made of? Like, if you could zoom in, and I mean way, way in, what would you even find? Well, the answer to that massive question is actually something incredibly small: the atom. It's the tiniest possible piece of anything. You can think of it like the ultimate universal Lego brick. Everything in the cosmos is built from these teeny tiny particles. But wait, what's an atom itself made of? It's not just one solid little ball. Oh no, it's actually a team of 3 even smaller particles working together. So let's meet the members of this all-star atomic team. Okay, here's the official stat sheet for our atomic players. First up, you've got the proton, and its defining feature is its positive charge. Then there's the electron, which has a negative charge. And rounding out the team is the neutron, which, as its name kind of suggests, is neutral. It has no charge at all. Now pay attention to where they live, too. The protons and neutrons, they hang out right in the center, while the electrons are zooming around on the outside. So, now that we've met the players, let's see how they actually come together to build their home, the atom. And when it comes to atoms, it's all about location, location, location. Right at the very heart of the atom, there's the super dense, tightly packed core. It's called the nucleus. And this is where the heavy hitters on our team live. Yep, inside that nucleus, you'll find all the protons with their positive charge and all the neutrons with their neutral charge, just bundled up together. These two guys account for almost all of the atom's total weight, or mass. But hold on, what about our third player, the electron? Well, the electrons are way too energetic to be stuck in that crowded nucleus. Instead, they are constantly moving in the huge space around the nucleus in these special zones we call electron shells. Now, these shells aren't just a random free-for-all. A great way to think about it is like lanes on a racetrack. Each electron has its own specific lane or energy level that it has to stick to as it zips around and around that central nucleus. Okay, so we know the players and we know where they hang out. But how do we tell one kind of atom from another? Well, every single atom plays by a strict set of rules, and these rules define its identity, its charge, and its mass. This brings up a really good question. I mean, if you've got all these positive protons and negative electrons flowing around, why isn't everything constantly zapping us with static electricity? How can atoms be neutral? Well, the secret is perfect balance. A proton has what we call a relative charge of +1, and an electron, it has a perfectly opposite charge of -1. They are a perfect match, designed to cancel each other out. You see, a standard, stable atom always has the exact same number of protons and electrons. So for every single positive proton in the center, there's a negative electron on the outside to balance it. It's this perfect one-to-one cancellation that makes atoms electrically neutral. All right, now let's talk about weight, or mass. If we say a proton has a mass of 1, then a neutron is also right around 1. But the electron, whoa, its mass is so incredibly tiny in comparison, it's almost nothing. It's like comparing a bowling ball to a speck of dust. That's why we say the nucleus contains pretty much all of the atom's mass. Okay, this next part is maybe the most important rule of all. The number of protons in an atom's nucleus is called its proton number. And listen, this number is the atom's official ID. It's like its fingerprint. An atom with 1 proton is always hydrogen. An atom with 6 protons is always carbon. No exceptions. The proton number literally defines what element you're looking at. Next up, we have the nucleon number. This one sounds complicated, but it's actually super simple. It's just the total count of all the particles inside the nucleus. All you do is add up the protons and the neutrons, and boom, that's your nucleon number. It basically tells you the atom's total mass.
So we can actually use these two numbers to do a little bit of detective work. If you know the total number of particles in the nucleus, that's the nucleon number, and you know how many of those are protons, the proton number, you can figure out the number of neutrons with some simple subtraction. Just take the nucleon number, subtract the proton number, and what's left over is your number of neutrons. See? Easy. Wow, you've learned a ton about the amazing atom today. So let's wrap this all up with a quick pop quiz just to see what really stuck. You ready to test your knowledge?
Okay, think back to our little atomic team. For each of the three particles, the proton, the neutron, and the electron, can you remember two things? What is its charge, and where does it live in the atom? If you can answer that, you've got a fantastic handle on the fundamental building blocks of our entire universe. Thanks so much for joining me on this little explainer.